Section 10.1 is triangles. I can solve problems involving triangles. Real quick recall here. When we classify a triangle by its angles, it's acute if they're all less than 90 degrees, right if one of them is 90 degrees, obtuse if one of them is greater than 90 degrees, and equal angular if all of our angles are the same. More commonly, we use equilateral, which means all of our sides are the same here. But equiangular, same idea, just with our angles. So all of our angles are the same. If a triangle is equiangular, it's also equilateral. When we classify a triangle by its side lengths, it's equilateral if all of our laterals or sides are the same, isosceles if two sides are the same, or scalene. So in example 1, we're going to be classifying a triangle by angle measures. In the diagram on page 511, which I kind of have here for you, the measure of angle DBE is 64 degrees. And the measure of BDE is the same as the measure of BED. So we're dealing with this triangle here. And the way that the letters are listed, guys, is important. It tells us the order, and that helps us figure out our angle. So DBE means 64 is in this corner. BDE is the same as BED. So we can set those equal to each other. Here I used a variable to represent that because we don't know what it is, so I'm going to use x, but it's the same value there. Both of them are x's because it's the same, they're equal, we just don't know what it is. So we have to find the measure of two angles, BDE and BED. Those are going to be the same, but in order to do that here, remember that our angles in a triangle add up to 180 degrees. Okay, so our first angle and our second angle and our third angle add up to 180 degrees. So we're going to combine like terms here. And then to get x by itself, now that I have both sides as simple as I can get them, I start moving from one side to the other. 64 minus 64 is 0, so I have 2x equals 116. Divide by 2 to get rid of our multiplication, and x equals 58 degrees. So if x is 58, that means the measure of angle BDE is 58 degrees, and the measure of BED. So the measure of angle BED is also 58 degrees because those are the same. Now we need to classify this by its angle measures. Here I have three angles, 64, 58, and 58. All of them are less than 90 degrees, so we call this acute. Now using the same diagram up here, given that the measure of angle, here I'm going to use the white, measure of EDG. So this is the triangle we're using, EDG. And EDG is 38 degrees. And the measure of DEG is 38 more than, so 38 degrees more than the measure of angle DGE. And we don't know what that angle is, so I'm going to make that an x. Now, because we know that all of our angles have to add up to 180 degrees, I can take each of my angles, 38 plus x plus 38 degrees plus x. Keep in mind those are in degrees. And set it equal to 180 degrees. So I took my three angles, added them up. Now I'm going to combine like terms. X plus x is 2x. 38 plus 38 is 76. Set it equal to 180. Now, left side's as simple as I can get it. Right side's as simple as I can get it. I can subtract. Okay, we always add or subtract first. Then multiply or divide. So x is 52, which means that the measure of DGE here is 52 degrees. And to find the measure of angle DEG, I had to take 38 degrees plus the measure of DGE, which we said was 52x. Add those up and I get 90 degrees. So the measure of angle DEG is 90 degrees. And it wasn't marked as 90 degrees, but it looked like maybe it was in our picture up here. But don't just assume. If it doesn't have the little thing like this to tell us that it's 90 degrees, it might not be. It might just be close. So we know now, though, that it's 90 degrees. And since we have a 90-degree angle, we call this a right triangle. In example 2, it says the perimeter of a scalene triangle. Perimeter means the distance around, and scalene means none of our sides are the same, is 65 centimeters. So our first side plus our second side plus our third side is going to be 65. Okay, we add up all of our sides. In a triangle, we have 3 sides, so we're going to add those up, and it's going to be 65 because perimeter is 65. The length of the first side is twice the length of the second side. So the first side we don't know. Let's make it x. Sorry, the second side we don't know. The first side on the bottom here we said is twice the length. Twice the length of the second side. So first length is twice the length of another side. Guys, it doesn't really matter how we draw this picture in here. What's important is we know that one of the sides is twice as big as another side. And the third side is just 20. So again, the length of one side is twice, which means 2 times the length of the second side. We don't know what that second side is, so we're going to make it our variable, and then 2 times that value, so 2 times x. And again, it equals 65. So I can take 2x plus 1x to get 3x plus 20. Again, we always want to combine our like terms, and I can put my x's together because my variables are exactly the same. Now that both sides are as simple as I can get them, we're going to get x alone by adding or subtracting first. So subtract 20 to get rid of my positive 20, my plus 20. And then multiplying and dividing. Since I'm multiplying by 3, I'm going to divide by 3. And x here is 15. So one side is 20. One side is 15 centimeters. X. And my other side is 2 times x, or 2 times 15. So 30 centimeters. So 15, 30, and 20. Something to keep in mind, guys, this is scalene, so they all have to be different, and they all also have to add up to 65. Now, feel free to pause here and give this a try. The perimeter of an equilateral triangle is 42 meters. Find the length of each side. So here, it doesn't look like it, but this is an equilateral triangle, which means that each of our sides are the same. We don't know what that is, so I'm going to make it an x for now. Okay, but we know that in an equilateral, all of our sides are equal. Here, to find the perimeter, we add those up. So x plus x plus x. And that perimeter is 42. So 1x plus another x gives me 3 x's equals 42. Divide by 3. And x is 14 meters. So the length of each side is 14 meters. The ratio of the angle measures of a triangle is 1 to 3 to 5. Keep in mind, guys, when we have ratios, we're comparing two things in its simplified form. So there was something multiplied by those that we divided out. We simplified it down to 1 to 3 to 5. So we're going to take and we're going to multiply again by that value. I don't know what that number is, so we make it a variable. It can change. It's unknown. And that's going to give me what my angles started as. We reduced them down to 1 to 3 to 5, but they started off bigger. We also know that angles in a triangle have to add up to 180 degrees. So one of my angles is 1x. Another is 3 times x. And my last one is 5 times x. And we know that those have to add up to 180 degrees. So 1 plus 3 plus 5 x's gives me 9x. So my scalar here, or what I multiplied, have to multiply by to get back to where I started, is 20. 9 times x, we divide by 9 and get 20. So 20 is not my final answer though. Keep in mind, that's how much I have to multiply these by to get back to where I started. So 1 times 20 gives me 20 degrees. 3 times 20 gives me 60 degrees. And 5 times 20 gives me 100 degrees. Keep in mind, these all have to still add up to 180 degrees. 20 plus 60 plus 100 does add up to 180 degrees. So we're good to go there. And if we reduce them, if we divided them all by the same number, we'd get back to 1, 3, and 5. Now, to classify it by its angle measures here, because one of my angles, 100 degrees, is greater than 90, it makes this an obtuse triangle. Now, the ratio of the angle measures of a triangle is 3 to 5 to 12. Find the angle measures, then classify the triangle by its angle measures. So, keep in mind here, guys, that if the ratio is 3 to 5 to 12, it means that those were all multiplied by something to start with. And we divided that out to get it in the simplest form, but we want to know where we started. We're trying to get back to the original angle measures. We also know that all of our angles, so one angle is 3x, and another angle is 5x, and my last angle was 12 times something, that x value. We add up all of our angles, and they have to add up to 180 degrees. Now, we got to figure out what that multiplier was, what we divided out. 3 plus 5 plus 12 gives me 20 x's. Divide to get rid of our multiplication. And here, x is going to be 9. 9 is not my final answer, though. Remember, that's my multiplier. Okay, so I have to figure out where each of these started. Okay, we took a 9 out of each of them. So to get back, we're going to multiply them by 9. 3 times 9 gives me 27 degrees. 5 times 9 gives me 45 degrees. And 12 times 9 gives me 108 degrees. When we add these all back up, we get back to 180 degrees, which is good. We should. 27 plus 45 plus 108 gets me to 180. So that's one good place to check to make sure we get back to the right amount of angle measures there. Last thing we want to do is classify it by its angle measures. And again, because 108 is greater than 90, this is going to be an obtuse triangle. And that's all I have for section 10.1.